Welcome back to our similarity and congruence. Today we are going to discuss about congruence. What is congruence? Two figures are said to be congruent if their corresponding sides are equal and their corresponding angles are equal. Now, congruence in triangles. It is not very necessary to check every side and angle to know if triangles are congruent. We can use congruent postulates and theorems to prove congruence in triangles. We have about five theorems or postulates concerning congruence of triangles. The first one, side, 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 or SSS criterion. In this case, you have three pairs of corresponding sides of the triangles which are equal. Now, if that is the case, the triangles are said to be congruent. Criterion number two is where we have two sides and an included angle. That is, if two pairs of corresponding sides of triangles are equal and the included angles are equal, then the triangles are congruent. Criterion number three, that's the case whereby you have an angle, side and angle. That is, the side is between two given angles. If two pairs of corresponding angles of triangles are equal and the pair of included sides are equal, then the triangles are congruent. Case number four is whereby we have two angles and a side, but this time the side is not included. The side is not included. In that case, two pairs of corresponding angles in triangles are equal and the pair of corresponding sides are equal, then the triangles are congruent. Finally, the fifth one is whereby we have a right angle, hypotenuse, and a side, shortly written as or said to be RHS. Now, in this case, if two pairs of angles are right angles and you have an hypotenuse with two pairs of other sides which are equal, then the triangles are said to be congruent. Note, the symbol, this one here, means is congruent to. This symbol here refers to is congruent to. Welcome back to the session of questions to illustrate the different postulates or theorems which we discussed above. Question number one. In the following figure, AB is equal to AC and D is the midpoint of BC. Show that angle ABD is equal to angle ACD. Solution. AB is equal to AC because we are told that we are given that information. AB is equal to AC. BD is equal to DC. The reason being that D is the midpoint of BC. And then, for that matter, triangle ABC should be an isosceles triangle since these sides, two of their sides are equal, and AD is the altitude since it is meeting the base BC at the midpoint D. It means that angle ADB should be equal to angle ADC and should be equal to 90 degrees each. For that matter, triangle ADB is congruent to triangle ADC for the reason that we have a right angle, hypotenuse, and a side, RHS. Henceforth, so long as these two triangles are congruent, then angle ABD should be equal to angle ACD from definition of congruence. In the figure below, we are given that AB is equal to DC and angle ABC is equal to angle DCB. We are required to prove that triangle ABC is congruent to triangle B is congruent to triangle DCB. DCB. So AB is equal to CD, that is given information. Similarly, angle ABC is equal to angle DCB, given information. And BC is a common side. From these three facts here, we can conclude that triangle ABC is congruent to triangle DCB by side angle side. Triangle ABC is an equilateral triangle and D is the midpoint of BC. Show that triangle ABD is congruent to triangle ACD. So below we have drawn the equilateral triangle ABC, where AB is equal to AC, of course, is equal to BC also because the triangle is equilateral. Now, so AB is equal to AC. Reason? Sides of an equilateral triangle. BD is equal to CD. Why? Because D is the midpoint of BC. And AD is a common side. It is common to triangle ADB and to triangle ADC. Therefore, triangle ABD is congruent to triangle ACD by SSS. Given the collateral ABCD, prove that triangle ABD is congruent to triangle CDB. Now, from the diagram, we can see that side AD is parallel to side BC. Therefore, angle ABD is equal to angle CDB because they are interior alternating angles. Similarly, angle ADB is equal to angle CBD for the same reason that this angle and this one, they are interior alternating angles. And again, BD is a common side. Therefore, triangle ABD is congruent to triangle CDB by angle side angle. Number 5, prove that triangle ADB is congruent to triangle ADC if D is the midpoint of BC. So we are told that in the given figure, we are given angle ABD to be equal to angle ACD. We can also see that AD is a common side to these two triangles, and angle ADB should be equal to angle ADC and should be equal to 90 degrees because D is the midpoint of BC. Therefore, in short, ABD equals ACD. Angle ADB equals angle ADC, and side AD is common. It means that using these three facts here, triangle ADB is congruent to triangle ADC by angle, side. Thank you.